Hello everyone. I'm going to try something new. I'm going to try to solve a problem and explain it as I go. Make this more like something I would do in class. So let's try this out. All right, this is a problem I got from one of you asking me to explain how to work it. So it's a word problem. Lots of you have been asking me about those. So here we go. It says one freezer costs $623.95 and uses 90 kilowatt hours of electricity each month. A second freezer costs $500 and uses 100 kilowatts of electricity each month. The expected life of each freezer is 12 years. What is the minimum electric rate in cents per kilowatt hours for which the 12-year total cost, which is purchase price plus electricity cost, will be less for the first freezer? All right, and then we have answer choices. So math, it's always easier if you think it out in words first. So they want us to determine when the cost of the first freezer is less than the cost of the second. And they're talking about doing this over 12 years. But notice that the price for electricity is in months, kilowatts per month, kilowatt hours per month. So we need to convert years to months. So 12 years is equal to 144 months. All right, and then I break down the costs further. So the cost, you have to include the fridge. That's a one-time cost. And then you have to add in the electricity. And that's the same for both sides. So for the first fridge, the cost was $623.95. And you add in the electricity cost, and it was 90 kilowatt hours. And you multiply that by the rate. And that's the one thing we don't know, because that's what we're solving for. But we do know we're going to use it for 144 months. That's 12 years of electricity per month. For the second fridge, it's a $500 cost, plus they have a rate of 100 kilowatt hours, but we're looking for the rate, and they're also going to use it for 144 months. So let's go ahead and simplify the things we know. We can multiply the 144 months by the kilowatt hours being used. So 144 times 90 gives us 12,960. And for the second fridge, 144 times 100 is 14,400 R. Now, normally when I solve equations, it doesn't matter which side you move things to. I try to keep the variable positive, but with inequalities, it's almost always better to solve everything to solve the variable on the left side. So to make that happen, I'm going to solve for the variable first. I'm going to subtract 14,400 R from 12,960 R. I get negative 1440 R. And then I'm going to subtract $623.95 from $500, and that gives me negative 123.95. And then to solve for the R, I need to divide by negative 1440, and that's no problem, but just remember that dividing by negative means you have to flip your inequality. So less than becomes greater than, and here a negative divided by a negative cancels out and gives us a positive. And always understanding your numbers. Remember, this numerator is dollars, $123.95, and the 1440 is the amount of kilowatt hours we're going to use. So when we divide those two, that gives us 0.08608, and it means that's dollars per hour, kilowatt hour. But they wanted it in cents per hour. So, well, there's 100 cents per dollar. So multiply 100, that number by 100, and you get 8.608 cents per kilowatt hour. And remember, it's not an equation, it's an inequality. So in order for the first refrigerator to stay cheaper than the second over 12 years, the rate has to be greater than 8.608 cents per kilowatt hour. If the rate were cheaper than that, then that would mean it would be better to go with the second fridge. All right, so math is fun. I hope you're doing better with this. It's going to take some time. I'll send this out to everybody. Let me figure out how to stop this. There we go, I think. Yeah. All right, I'll send that out as a PDF and a YouTube link, and keep your questions coming.